Hello, in this lecture we will find the radius of a circle. In the drawing we have a circle and inside the center of this circle is at point O, and inside the circle we have a rectangle, and the size of this segment is 6 units and the size of this segment is 3 units, and we want to find out the radius of this circle. First of all, we will define this point as M. Again, line segment CM is 6 units in size. Line segment CM is 6 units in size, and also we will define this point as point N, and the line segment AN equals to 3 units in size. Okay. Actually, in the next step we will define the size of OM. We will define the size of line segment OM as Y, line segment OM equals to Y, and we will also define line segment ON as X. Okay, or ON, line segment ON equals to X. Actually, line segment OC is the radius of this circle, because of the fact that line segment OC starts from point O, that is the center of this circle, and ends at point C, that is the point of the circle itself. For that reason, line segment OC is the radius of this circle. Okay, line segment OC equals to R, the radius of this circle, and also line segment OA is the radius of this circle for the same reason, because it starts from point O, that is the center of this circle, and ends at point A, that is the point of the circle itself. For that reason, line segment OA is also the radius of this circle. Okay, line segment OA equals to R, that is to say, line segment OA is the radius of this circle. So, because of the fact that both those line segments are the radiuses of this circle, they are of course equal to each other, so we can write the first equation that OC equals to OA. Okay, OC equals to OA. Our first equation states that line segment OC equals to OA because both of them are radiuses of this circle. OC equals to OA because both of them are radiuses of this circle. Okay, but line segment OC equals to y plus 6. Okay, line segment OC equals to y plus 6. So we can substitute OC in the first equation by y plus 6 because OC equals to y plus 6. And line segment OA equals to x plus 3. Again, line segment OA equals to x plus 3. So we can substitute OA in this equation by x plus 3. So actually we got in the first equation that y plus 6 equals to x plus 3 because we substituted OC by y plus 6 and we substituted OA by x plus 3. So we got that y plus 6 equals to x plus 3. Now we will subtract 6 units from equation number 1. So we subtracted 6 units from equation number 1. Y plus 6 minus 6 equals to y, and x plus 3 minus 6 equals to x minus 3 because 3 minus 6 equals to minus 3. So in total we got that y equals to x minus 3. Okay. But I mentioned in the beginning of the lecture that inside the circle we have a rectangle. Actually, shape MBOA, shape MBON is a rectangle, and in a rectangle the parallel sides are equal to each other. So if OM equals to y, then BN that is parallel to OM will be also equal to y because of the fact that in a rectangle the parallel sides are equal to each other. So OM is parallel to NB. For that reason OM equals to NB, and if OM equals to y, then NB will be also equal to y. But we have already found that y equals to x minus 3, so we can add here that y equals to x minus 3. Okay? And actually line segment OB is also the radius of this circle because of the fact that it starts from point O, that is the center of this circle, and ends at point B, that is the point of the circle itself. For that reason, line segment OB is the radius of this circle. But OA is also the radius of this circle, and it equals to x plus 3. So if OA, that is the radius of this circle, equals to x plus 3, then OB, that is also the radius of this circle, will be also equal to x plus 3. Okay, so OA equals to also to x plus 3 because it equals, OB equals also to x plus 3 because it equals to OA, that is also the radius of this circle, and OA equals to x plus 3, so OB, that is the radius of this circle, also equals to x plus 3. Okay, so actually we know that in the, first of all, triangle ONB is a right triangle because of the fact that inside the rectangle all the angles are right angles, or all the angles are equal to 90 degrees. So angle ONB equals to 90 degrees, and for that reason triangle ONB is a right triangle. So in the right triangle ONB, in the right green triangle ONB, we know that the hypotenuse equals to x plus 3. Side ON of this right green triangle equals to x, and side BN equals to y, that equals to x minus 3. So the only variable that is missing in this right green triangle is x. And we actually can use the Pythagorean theorem in order to find out the value of x. According to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So that is to say, the square of the hypotenuse is x plus 3 square. So our second equation will be x plus 3 square equals to the sum of the squares of the perpendiculars equals to x square plus x minus 3 square. Again, according to the Pythagorean theorem, the square of the hypotenuse, that is to say x plus 3 square, equals to the sum of the squares of the perpendiculars equals to x square plus x minus 3 square. Okay, now we will open the brackets in this equation. So we opened the brackets in this equation, x plus 3 squared equals to x squared plus 9 plus 6, according to the formula that a plus b squared equals to a squared plus b squared plus 2 times ab, when a equals to x and b equals to 3. Okay, and it equals to x squared plus x minus 3 squared, and x minus 3 squared equals to x squared plus 9 minus 6x, according to the formula that a minus b squared equals to a squared plus b squared minus 2ab, when a equals to x and b equals to 3. Okay, now we have x squared in this side of the equation and x squared in this side of the equation, so you can cancel x squared because we have x squared in both sides of the equation, and we have 9 in this side of the equation and we have 9 in the other side of the equation, so we can cancel y. We can cancel 9, we have 9 here and here, so we can cancel 9. So what is left from equation number 2 is so in this side of the equation, what is left is 6x, so I copied it here. And in this side of the equation, what is left is x squared minus 6x, so I copied it here, x squared minus 6x, so we got that 6x equals to x squared minus 6x. Now I will subtract 6x from this equation. So I subtracted 6x from this equation. 6x minus 6x equals to 0, and x squared minus 6x equals to x squared minus 12x, because minus 6x minus 6x equals to minus 12x. So in total we got that 0 equals to x squared minus 12x. In the next step, we will take out a common factor x from this equation. Again, we will take a common factor x from the second equation. So we took a common factor x, we took out a common factor x from this equation. We got that 0 equals to x times x minus 12. Actually, we have two solutions to this equation. The first solution is that x equals to 0, but it's impossible that x equals to 0 because x is the side of the triangle and it's also side of the rectangle, so it can never be 0, it must be a positive number. So x equals to 0 is not correct solution, and the other solution is that x minus 12 equals to 0, and if x minus 12 equals to 0, then x equals to 12 units. Okay, if x minus 12 equals to 0, then x equals to 12 units. Okay, but the radius of this circle equals to x plus 3, so the radius of the circle will be equal to x plus 3 okay, the radius of this circle equals to x plus 3 and x is 12, so the radius of this circle equals to 12 plus 3, that is 15 units. Again, the radius of this circle equals to x plus 3. X plus 3 is 12 plus 3 because x equals to 12. So the radius of this circle equals to 15 units. That is the answer to the question. Now I will summarize the lecture. Actually, we wanted to find out the radius of this circle. We know that the center of this circle is at point O, and inside the circle we have a rectangle, and we want to find out the radius of this circle. We know that also line segment MC equals to 6 units and line segment AN equals to 3 units. So we defined line segment OM as Y and line segment ON as X. And actually line segment OC is the radius of this circle because it starts from point O, that is the center of the circle, and ends at point C, that is a point on the circle itself. So actually line segment OC is the radius of this circle. Okay, so we wrote that OC equals to R, that is the radius of this circle. And also line segment OA is also the radius of this circle because of the fact that it starts from the center of the circle, that is to say from point O, and ends at point A, that is a point on the circle itself. For that reason, OA is the radius of this circle. Any line segment that starts from the center of the circle and ends at any point on the circle is defined as the radius of that circle. And actually line segment OC and line segment OA satisfy the definition of a radius of a circle. For that reason, both of them are radiuses of this circle. But we know, so because of the fact that both line segments OC and OA are the radius of this circle, they actually are equal to each other, so OC equals to OA. So first the question is that OC equals to OA because both of them are radiuses of this circle. But we know that OC equals to y plus 6. So we can substitute OC by y plus 6. And we also know that OA, that is the radius of this circle, equals to x plus 3, so we can substitute OA by x plus 3. Okay, so we got that y plus 6 equals to x plus 3. We substituted 6 from equation number 1, and we got that y equals to x minus 3. Okay, y equals to x minus 3, but inside the circle we have this rectangle, and in any rectangle the parallel sides are equal to each other. So if OM equals to y, then side NB of the rectangle will be also equal to y, because of the fact that in a rectangle the parallel sides are equal to each other. So if OM equals to y, then NB that is parallel to OM also will be equal to y. So NB also equals to y. But we know that y equals to x minus 3, so we can write here that y equals to x minus 3. Okay, and actually line segment OB is also the radius of this circle, because of the fact that it starts from the center of the circle, that is to say from point O, and ends at point B, that is the point of the circle itself. For that reason, line segment OB is the radius of this circle. So both line segments OB and OA are the radiuses of this circle. But we know that, so OB equals to OA, because both of them are radiuses of this circle. But we know that OA equals to x plus 3, so OB that equals to OA will be also equal to x plus 3. Again, we know that OA equals to OB because both of them are radiuses of this circle, and OA equals to x plus 3, so OB that equals to OA will be also equal to x plus 3. Okay, so in the right green triangle, triangle ONB, and actually triangle ONB is a right triangle, because in a rectangle all the angles are equal to 90 degrees. So angle ONB equal to 90 degrees. For that reason, triangle ONB is a right triangle. So in a right triangle we have the Pythagorean theorem that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, x plus 3 square equals to x square plus x minus 3 square. Okay, according to the Pythagorean theorem, in the right green triangle ONB, the square of the hypotenuse, that is to say x plus 3 square, equals to the sum of the squares of the perpendiculars, equals to x square plus x minus 3 square. Okay, that is according to the Pythagorean theorem. And we solved this second equation, and we found out that x equals to 12 units. Okay, x equals to 12 units, but the radius of this circle equals to x plus 3. OB is the radius of this circle, and it equals to x plus 3. So the radius of this circle equals to x plus 3, and x equals to 12. So the radius of this circle equals to 12 plus 3, that is 15 units. Okay, the answer to the question is that the radius of this circle equals to 15 units. Okay, thank you very much.